Alrighty, welcome geometry friends. We are on homework, and I just saw an error. This is homework 2.6, not 1.6. Homework 2.6 with the exercises, where you're going to be doing page 113, numbers 1, 5, 9, 11, 13, 21, 25, and 27. Alrighty, might be a little bit of a challenging one, at least the proofs, but I'll be working through those proofs with you just to give you more and more experience, because that is the key. And anyway, we'll get through this together. You can do it. Statements and reasons. So jumping right to, which actually I think is the answer number 1, statements and reasons. But let's go ahead and jump to number 5, where it says, use the 2-column proof to prove, they tell you that x is the midpoint of AY and y is the midpoint of XB. Prove AX is equal to YB. And so what I have here is I've included the drawing. Okay, so first of all, start with what they told us. They told us, and I actually always recommend kind of marking things up on the drawing, but let's go ahead and start. So first we're going to need our statements, and then we're going to need our reasons. Okay, this is what we mean by a 2-column proof. We've been doing these since 2.5. So we're going to separate those, and we're going to start with what they tell us on the left side. So always start, the key to start is start with a given. Okay, so we got our left and our right. We need to prove, basically, let's look at our drawing here. Well, actually, we need to prove that, what does it say? That AX is congruent to YB, okay? And we would start with what they told us so far. So they told us that x is the midpoint of AY and XB. So I'm going to put that. Alrighty, x is the midpoint of AY. Okay, so what that means is that x equally cuts AX and XY into 2 equal halves. Okay, and they told us that y, I think I said x a minute ago, y is the midpoint of of XB. There we go. XB. So in other words, y is in between x and b. So that means that segment XY and YB must also be congruent. Okay, well, why would they tell us before? Actually, those are reasons. Let's get all the points we can. We know that's true. How did I know that those were the midpoints? They were given to me. So again, proofs, statements on the left, reasons on the right, and then the first step you always want to make is with the givens. Okay, so what's the value? What's the value in knowing that those are the midpoint? Because usually the given is always a clue as to what you should be then doing next. Well, it's what I marked. Let's go ahead and state that if x here is the midpoint, then that means that this piece is the same as this segment. So let's try that. So AX is congruent with XY. Okay, and how do I know that? That's because that's the definition. I'm using that because they told us they were midpoints. So it's from the definition of a midpoint. Because they are midpoints, I know that they've created these 2 congruent pieces, AX to XY. And I know the same thing. Switch colors here. I know that Y, because it's a midpoint, it's created these 2 congruent segments, XY and YB. Sorry, it doesn't all fit on here all at once. But so we also know that XY, oops, to write a little smaller here to fit it, XY is congruent to YB. All right, and it's the same reason, definition of a midpoint. Now again, so first clue is use your given. Second clue is take your given and what does that given based on its definition imply? That can usually be your next step. Then once you do that, kind of pause and go, okay, what was I trying to prove again? I'm trying to prove that AX, this, is congruent to YB, this. Oh, wow, wait, look, I've seen this before. If AX is the same as XY, and XY is the same as YB, therefore, AX and YB must be the same. And I actually have a word for that. That is by the transitive property of equality. And so you don't, the red stuff, I just drew that, you don't put that on your proof, but I was just trying to illustrate my logic. That by extrapolating that these segments are congruent because they have midpoints, then I can see that, therefore, AY or AX, segment AX, is congruent to segment YB by transitive property of equality. Okay, and that's the thing that they asked us to prove, going back to the beginning, so that means I'm done. I have a reason for every statement I gave. I used my givens. I drew a conclusion from my givens, which was these congruent segments. And then from that, I was able to spot via the transitive property that therefore AX must be congruent to YB. Alrighty, so there's a good example of a basic geometric proof. So let's keep practicing. Let's try a different one. It's going to be a little different, but the more we do, the more you get good habits and kind of figure out how these things work. So let's go ahead and start with, we're going to do number 9. Let me get my statements and my reasons ready. Form your 2 columns. Okay, and where do you always start? On the page, be ready. It says given, and it says that BE is congruent to CE, DE is congruent to AE. All right, so in other words, these red marks have been given that AE is the same as DE, and then the shorter pieces B to E and C to E are the same. That's what those red hash marks mean. Okay, so then that's where I'm going to start. I'm going to say that AE is congruent to DE, and CE is congruent to BE. How did I, oops, E. And let's fix that. BE. Okay, how did I know that? What was my reason? They gave it to me, given. I'm not going to write given once for both, or I'll just write it twice since I got 2 lines there. Okay, now, what are we trying to prove? Okay, we're going to try to prove that the entire A to B is congruent to the entire C to D, so that this, I'm trying to prove that this is congruent to this. Okay, well, let's see, what can I do next? I can see that if I'm trying to prove the entire lines, I might want to go ahead and make the statement that how the lines add up. So in other words, I could say that AE plus BE, those are the 2 smaller pieces horizontally, they equal the full segment AB. Since I'm going to have to prove AB is congruent to something, I might as well determine the pieces that go into AB. And I could say the same thing for the vertical line. I could say that DE plus CE equals CD. Okay. Now, how do I know that? How do I know, what have we talked about, where the 2 pieces or the 2 segments add up to the combined segment? That is called the segment addition postulate. Segment addition postulate. And again, I'll just can write that twice because I used it twice. Now, this is about the time where you go, okay, wait, why am I saying all this? And sometimes you'll do something and you'll take a step and you'll erase it because you realize, that actually doesn't really help. But what I can see here is I'm trying to get these 2, A, B, and C, D, that they're equal to each other. And I can see that the parts of A, B, even though, again, it starts to kind of get into alphabet soup, but the parts of A, B are congruent to their matching parts of CD. In other words, what I said up here was I said AE is equal to DE, and I said CE is congruent to BE. So that means I can start to do substitution. I can start to kind of sneak an equality between these 2. So in other words, let's take AB. AB, which I've already said is equal to AE plus BE, but what if I substitute what they're equal to? In other words, instead of AE, I could say that's DE. Instead of BE, I can say that that's CE. So I can substitute and I can say that the whole line AB is equal to the parts of the CD segment. Okay, and that is whenever you just replace something that's equal to something else, you can use the substitution property of equality. See that? And so that when again, I'm doing that because I can take my given and then my segment addition postulate steps and go, okay, what do they combine to mean? Well, it allows me to replace the insides and say that, again, the parts of CD, DE, and CE are also equal to AB. Now, can I pull off a similar substitution and say, well, in other words, I have CD or DE plus CE. Well, I know what that's equal to. I know that DE plus CE is also equal to CD. So why not replace this with that? It's kind of like, I don't know, a relay race. I don't know if that's a great analogy. But I can now, instead of writing DE plus CE, I can just say, well, CD then is congruent or equal to AB, right? Because the power of that is that's what I've been asked to prove. I've been asked to prove that AB is equal to CD. And there it is right there. And all I did was I did another step of substitution. And you can see how if you tried to do that on your first try, you might be like, I had no idea that that's how we could prove it. And that's why I'm just going to say again and again and again, practice, practice, practice. The more you practice and the more you learn kind of the different strategies for manipulating information to get to your proof, just the more confident you'll get in working with these. But I'll reemphasize that we started with the given, and then we looked at what we needed to prove to see what else we could generate, and we finish with the actual, your last step should always be exactly what they asked you to prove. I will add that if you might say, well, wait a minute, they said to prove that AB was congruent to CD, not CD is congruent to AB. Short answer is that's the same thing. Who cares? If you want to just kind of be like over the top all-star, you could go ahead and rewrite it just to throw in another step to show that you're with it. You could rewrite that and say, I know a reason why I can switch it. I know why Mr. Mefford's saying it's the same thing. It's because of the symmetric property of equality. This is not a necessary step, but it shows you're paying attention and that you're diligent and it's covering all your bases. Alrighty. Review that section to kind of get a better handle on how we do that proof, but I'm going to move on to number 13. These are not proofs, praise the Lord. So a little simpler, but just working with this idea of congruent complements and congruent supplements. Number 13 just says find the measure of each angle. And so it says to find the measure of angle, this one right here, we need to find the measure of angle 3. All right, so let's take a look at it. First of all, I can see that I have complementary angles here, 31, and an unknown angle here. But I can see that they are complementary. They add up to 90 degrees. So that's pretty easy. That means the total is 90 degrees and one angle is 31. So how do I find this missing angle? I just do 90 minus 31. And so that angle must be 59. So this angle here is 59 degrees. So you're practicing that. You should always be able to find complementary angles. But then they're trying to emphasize that, okay, if we look at this picture here, the angle 3 that we're actually trying to find right here is congruent to the angle over here. So that means this one must also be 59 degrees. So by finding the missing angle on the left, I can then conclude what the measurement of the degrees of the angle number 3 on the right is. We also would know, of course, that this angle, therefore, if that's 59, this angle here is 31. That's going beyond what the question's asking. All righty. Number 21, same type of idea, except now we have supplementary angles. These are supplementary angles. And so because 9x minus 6 is supplementary to this angle, and we know that 8.5x plus 2 is supplementary to this angle, and these two are congruent, that means these two must also be congruent. That's the example of the supplementary. It's called the congruent supplements theorem. That's the same as the congruent supplements theorem, even though I forgot the name of it for a second. So all that to be said, we know that we can set these two equations equal to each other and solve for them. 9x minus 6 is the same as 8.5x plus 2. Because although they aren't, anyway, we'll keep going. So let's go ahead and pull out our algebra. We're going to subtract 8.5x to put our x's together. I'm going to go it this way, so I keep it positive. That cancels out. And so that leaves us with 0.5x minus 6 equals 2. If I was doing an algebraic justification, I would say subtraction property of equality. If I was doing to set for the first part of my equation, I could set it up as congruent supplements theorem. That's how I knew that these two had to be congruent to each other. Alrighty, then we need to go ahead and add our 6 to both sides, because that'll cancel out the negative 6. So 0.5x equals 8. Alrighty. And then we need to just divide by 0.5, division property of equality. You don't have to give the justifications for this problem, so I'm not going to. But we could. And so now I can see that x is equal to, well, how many halves go into 8? 8 holes go in, but so if half, that would be 16. Or if you want to do it in the calculator, that's fine, but x is equal to 16. And it said for this one, find the value of the variable, so I don't have to plug it back in. I am simply done because I found out that x equals 16. All righty. Let's go on to 27. 27 is a multiple choice problem. Lots of words, so it might be good to take notes and digest them. That's what I wrote here. 27 says two angles are complementary. Okay, so already I can see, oops, I wrote the wrong words here. The two angles are complementary. What does that mean? Well, that means they add up to 90 degrees. Okay. It also says that one angle is 10 less than the other one. So that's why I wrote here, one angle is x, the other angle is x minus 10. And then it goes on to say that one of the angles is 85. Whoops, I wrote that wrong. One angle is 85, the other one is 95. Okay, well, that makes sense. 85 is 10 less than 95. And then it says, so which statement is true? The conclusion is correct because 85 is 10 less than 95. Yeah, kind of. The conclusion is verified by the first statement given. Oh, what was that first statement? Oh, it said that the two angles are complementary. Are 85 and 95 complementary? Complementary means they have to add up to 180. No, these are actually supplementary because they add up to 180 degrees. So there's no way B is right because actually this is impossible. They can't be 95 and 85 because that would be supplementary, not complementary. So that makes me think, the conclusion is invalid because the angles are not congruent. No, nothing in the statement said that they're not congruent. D says the conclusion is contradicted by the first statement given. Aha, yes. There's no way the conclusion that 95 and 85 are the right answers is contradicted because no, they have to add up to 90 degrees, not 180. So I'm going to go with D. I can't emphasize enough that if this is hard for you to kind of write out step by step what's being said, to visualize it a little bit more, because just trying to internalize it all in your head, it's kind of easy to become kind of a jumbled mush. Alrighty, well, I hope this helps, and reach out if you have any issues with the proofs. We'll be practicing these on Thursday, and then also we'll have our quiz on Friday. All right, see you soon.